A very good morning to all of you on my lecture on goal programming for solving multiple objective problems, a practical approach. I introduce myself as Dr. Rabindranath Bhattacharya. I am an adjunct professor with Vinod Gupta School of Management, IIT Kharagpur. The second slide shows my resume or curriculum vitae, and you can go through it whenever you find time. I will not spend much time on this. Let us come to the subject, goal programming. In fact, when you look at some real life scenario, you will face multiple objectives. It's very difficult to find out a scenario where you will not have more than one objectives. And these objectives which will be really conflicting, and it is not possible for a single solution for the problem, or it's not possible to get an optimized solution for these conflicting objectives. This compromised solution is based on the relative importance of the objectives. Now, if you look back and find out what we did actually when we did the programming in operation research. Now, in OR or operation research, when we did some programming, we had one single objective function that expressed everything, the overall measure of performance. In fact, either you should maximize something or minimize something, and so there are two types of problems. One is a maximizing problem, another is minimizing problem. So in case of maximization problem, we had profit, production, etc. And when it is a minimization problem, it comes to you can take cost, you travel minimum distance, or consumption of raw materials, or something else. Basically, there are two types. But question is, can you use linear operation research techniques we have learned so far to find out a solution for the goal programming? Now, with goal programming, you are supposed to simultaneously optimize your cost or minimize your cost, maximize your production, and as well minimize your labor. Now, what to use when you desire to achieve a solution that is best with respect to a number of different criteria, as mentioned above: minimization of cost, maximization of production, and minimization of labor. For example, so if we take some examples from industries, we have different objectives. Suppose you are working in a manufacturing company, and we generally concentrate on cost reduction. But if you totally concentrate on cost reduction, you might neglect the environmental or social concerns of the community you serve. For example, if you are in a healthcare company, if you concentrate mostly on top quality health care, the profit of the company may have to be sacrificed. Suppose you are working in a publishing company, and if you put too much emphasis on developing an error-free textbook, the amount of time spent for review may go haywire, and this may result in pushing the publishing date beyond the target date agreed upon. So I've given 3 examples. It may be different. There are hundreds of examples where you can utilize goal program. So what is the real scenario and what is the objective? Number one, you have to accept all the time that it is not always possible to put all management objectives into one overall measure of performance. So this truth you will have to accept. And objectives might be so different that no common basis for measuring progress towards these objectives. In fact, achieving a minimum profit, no reduction or increase of employees, work within a budget, and hold the capital expenditure within certain limit. Now, these are the objectives which you will have to maintain when you are working in a manufacturing organizations, for which you will be given targets by your higher management. So what management wants from you? Management might instead set numerical goals for the various objectives, and they will give priorities, and they will seek a solution that makes as much progress as possible towards these goals. So goal programming model seeks to simultaneously take into account several objectives or goals that are of concern to a decision maker. So you must remember that we will have to take simultaneously all the objectives and work out a solution. And in the process, you might achieve some goals and you might be out for some goals. In some goals, you might underachieve, and in some goals, you might overachieve. So goal programming model consists of a set of goals that are prioritized. In some sense, you will have to give a priority. Suppose, for example, whether the profit is a priority or raw material cost reduction is a priority, more priority than profit. This you will have to, management will give you. And an objective function to minimize the deviations. So in goal programming model, what you minimize, you actually minimize the deviations, or it may be some of deviations also, above or below the target. That means if you want some profit, say for example, more than 125 billion. Now in that case, under the target is penalized. That means you are not supposed to get a profit less than what is the target. Similarly, for budget, it must be below the budget. That means you cannot go above the budget. So in this case, you'll have to work on both above the target and below the target, and you'll have to minimize the summation of the deviations. Let us take an operation research problem. Now, a linear programming model comprises of many constraints. So you must have seen in your work problems. It consists of a number of constraints and a single objective function to be maximized or minimized. So what happens when you go for GP formulation? Here you will have to minimize total weighted deviations from goals, subject to, these are the constraints, expressions for goal equations. So you have certain constraints for goal equations, then you have certain functional constraints, and then you have non-negativity constraints for decision variables, and you have also non-negativity constraints for all deviation variables. So these are the two things which you will have to keep in mind, that you will have to work with both decision variables as well as deviation variables in many cases, whereas in case of OR you will be dealing with only decision variables. So this is the difference between the two, and you will have to, objective function will be to minimize the total weighted deviations from goals. So how to treat multiple competing objectives? Select one criteria as primary and the remaining criteria as secondary. Then primary criteria is then used as an optimizing performance measure, and the secondary criteria are treated as problem constraints by assigning acceptable minimum or maximum values. Lastly, carefully select acceptable levels to get feasible solutions. So ultimate objectives, if you compare linear programming and goal programming, if the constraints are inconsistent, then there are no possible feasible solutions of the model in both LP as well as GP. In GP, however, you can expect that although there is a set of feasible solutions satisfying the constraints, none of them satisfy all the conflicting goals. You cannot expect to satisfy all the goals. The objective of this GP is to find a solution that satisfies the true constraints and comes closest to meeting the stated goals, which is called in management term the most satisfying solution. So in goal programming, you can get only the most satisfying solution, and it is not optimum solution. So example is better than precept. So let us take one example. Now we'll solve it graphically and see how it goes. Maitra, it's an American company. It's a growth oriented firm. It has sales force and per month available hours is 640 for the visits of the salesman. Further, it is estimated that each visit, so they are visiting simultaneously both old client as well as new clients. Now for new clients, naturally it will take more hours, so it takes 3 hours, and each visit to a current client takes 2 hours. And WebNet, the company who markets their services, they have set the goals for the coming month. So what is the first goal? First priority, contact at least 200 current clients. Second priority, contact at least 120 new clients. Now over achieving either goal will not be penalized. So we are assuming that they are not being penalized. That means penalty weights are not given. Let us solve this problem with OR technique, operation research linear programming. Now objective function, OF is the objective function. Here it is objective function. We want minimum how many hours is required to visit all the suppliers with goal 1 and goal 2, the constraints. So for example, goal 1 is x1 must be greater than equal to 200, whereas goal 2 is x2 must be greater than 120. Non-negativity constants for decision variables, here no deviation variables, and our objective is to minimize z equal to 2x1 plus 3x2, because old client takes 2 hours and new client takes 3 hours. If we solve it in solver, this is the solver screen. I have put it here for your benefit, and this is greater than equal to 200, so one constraint. The second constraint is greater than 120, and this is non-negativity constraint. So if you solve it, you will get, this is the solver screen, and the objective function is 760, and x1 equal to 200, so x2 equal to 120. So the minimum hours would be 760. So below, if you keep below 760, then you will have to sacrifice either x1 and x2. So that is how the goal programming comes in the picture. Suppose the available hours is less than 760, then what will you do? This problem is very simple, so you can easily say that I will do one thing. Since first priority is x1, I will keep 200 and I will reduce x2 by something. So it may be 30, 40, 50, 60 or whatever it is. But exactly you will have to calculate and find out. So let us do the goal programming formulation. x1 is greater than equal to 200. This is the goal 1 first priority, and goal 2 is x2 greater than 120 second priority, and hours constraints is given. So this is called functional constraint. So in functional constraint we have put 1, and goal constraint we have put 2. Now non-negativity constraints for decision variables xi is greater than equal to 0, and for non-negativity constraints for deviation variables di is greater than or equal to 0. So this is the formulation. So if we write in terms of d1 and x1, it will come like this. So objective function is minimize deviation d1 minus plus d2 minus, because we have a condition that x1 should be greater than 200. So we'll try to convert, take d1 minus as 0 and d2 minus as 0. So if we can minimize this d1 minus plus d2 minus, then we'll be able to achieve our objective. That means it will be either equal to 200 or greater than 200. And when you make d1 minus and d2 minus both 0, if suppose you are able to do it, then in that case d1 plus might have a value and d2 plus might have a value. So you cannot have values for both d1 minus and d1 plus simultaneously, or d2 minus and d2 plus simultaneously. So either of them will be 0. And this is the functional constraints, and xi decision variables, non-negativity constraints. So the formulation is like this. Let us solve it graphically. So the first equation, 2x1 plus 3x2 equal to 640. So let us draw the graph. And when x1 equal to 0, x2 equal to 213, when x2 equal to 0, x1 equal to 320. So let us plot the line, and it comes like this. That means you cannot go above this line. You will have to always go below this line. So any point optimum solution must be below this line. It should not go outside this line. Now you have seen that for x1, the constraint is x1 plus d1 minus minus d1 plus equal to 0. So from the previous slide you can easily find out 200, that is goal 1, and x2 plus d2 minus minus d2 plus equal to 120. So these are the goal constraints, and the earlier one is functional constraints. Now suppose I plot the line for x1 equal to 200 and x2 equal to 120, I will get like this. So in this case, my optimum points should be within this line, and goal 1 constraint, the point should be on this line or away from this line, and for goal 2 it should not come below this, it should go up only. And if you want to satisfy all these 3 conditions, you get 2 points here and here. So 140, 120 is 1 point and 280 is another point. So we have 2 optimum points. Now which one will you select? You will select that point which will give you the minimum deviation, summation of deviations. So if you the objective function is minimize d1 minus plus d2 minus. So in this case 0 plus 40, whereas in this case it is 0 plus 60. So since 60 is greater than 40, so we'll choose this value. That means 280 is the point which we should choose. So if it is x1 is 200, that means goal 1 is achieved. But if x2 is not achieved, because the value we are getting is 80, so goal 2 is not achieved. So how much short is this? So it is short by 40. So goal programming has got a solution which is, this is the most satisfying solution, and you have been able to achieve the first objective, but second objective you are slightly short. This is the Excel method, and objective function, you must have noted, I have put it 1.5 d1 minus plus d2 minus because it is 2 and 3, so I can roughly say, I can easily say that it is 1.5 times more important than this. So the objective function, if you put it 1.5 d1 minus plus d2 minus, I'll get 40. That means this is the shortage I get. So 200 is for x1, this is for 80, constant is maintained, goal 1 is maintained, but goal 2 is down by 40. So the method which we adopted earlier is called weighted method. That means I have given certain weights to the deviations. For deviation 1, I have given 1.5, and for the deviation 2, I have given 1 only. But suppose you don't have the weights with you. What we'll do, we'll go for first goal optimization. So in this case, I'll go for minimization of D1 minus and solve the problem. And I will get D1 minus equal to 0. If I take second priority, assuming D1 minus is 0 and minimize D2 minus, I'll get 40. So goal 1 is met, goal 2 is not met, short by 40, constant for hours is met. So is it not the same as what we found out by graphical method? Exactly, it's the same. Let us take a complex problem where you have a company manufacturing power tools in the United States. The company is preparing to replace its current product line with the next generations of product. So they have got P1, P2 and P3. So there are 3 power tools which they are going to introduce. So they are going to replace its current products. So management needs to determine the mix of the company's 3 new products to best meet the following 3 goals. Achieve a total profit of at least $125 million, which means that it should be greater than equal to 125 million. Maintain the current level of employment. That means neither you can go below 4,000 nor you can go above 4,000. And hold the capital investment down to no more than 55 million. So we have 3 objectives. So will it be possible to attain all these goals simultaneously? All are important, but by small margins, and their order of importance is given by goal 1, profit level, part of 2, goal 3, capital investment, and goal 4, part of goal 2, avoid increasing the employment level. So first priority is goal 1, maximum priority, then comes the reduction of the employment level, second priority. Third priority is capital investment must be less than 55 million US dollars, and fourth is the last priority. That means you, if necessary, you can increase the number of employment level. So total profit, so penalty weights have been given. These are weights given. So 5 for the first goal per 1 million under the goal. Employment levels 4 per 100 under the goal, and per 100 employees over the goal. Capital investment 3 penalty weights per 1 million over the goal. So these penalty weights have been given. So we'll use weighted method for goal programming. Now if we come to the contributions for each product, for each of the value, each of the constraints or goals, total profit for Product 1 is 12, product 2 9, and product 3 15. Employment level for product 1 5, for product 2 it is 3, and for product 3 4. And capital investment 5, contribution of first product is 5, for the second product it is 7, and for the third product is 8. Should be less than equal to 55 million. So with weighted goal programming, the objective is to minimize the weighted sum of deviations from the goals. And here weights are the penalty weights, which is already given. And introduce new changing cells, amount over and amount under, that will measure how much the current solution is over or under the target. The amount over and amount under changing cells are forced to maintain the correct value with the following constraints. So level achieved minus amount over plus amount under is your goal. But remember, amount over and amount under both cannot exist simultaneously. So if amount under is 0, then amount over will have some value. This way of formulating the model makes it an LP model. So the formulation, Pj is the number of units of products, j equal to 1, 2, 3. Under goal I, goal 1, di minus, over goal is di plus for I equal to 1, 2, 3. An objective function thus becomes minimize z, which will be 5 into under goal 1, 2 into over goal 2, plus 4 into under goal 2, plus 3 into over goal 3. Or minimize 5 d1 minus, this is the profit constraint, this is the employment extra constraint, this is employment reduction, and this is the budget. 3 is for budget. So from here you can make out that employment reduction, first priority is profit 5, this is 4, and this is 3, and the last priority is extra employment. That means in case it is necessary, you can employ something extra if it comes so. So I'll complete the constraints, putting the terms minus d1 plus d1 minus for the first goal, for the second goal d2 minus, d2 plus, and for the third goal d3 plus and d3 minus, and all equal to 125, 40 and 55. Pj, as I have already said, it's 1 to 3 decision variables. Deviation variables are also 1 to 3. For plus and for minus it is 1 to 3. So Excel formulation, we have done it, and if you see this objective function, this is equal to 5c2 plus 2c8 plus 4 3, whatever is given by the management. And what we observe, that's for goal 1 it is okay, and for goal 2, that is employment, it is for actually below employment below the target is not is 0, so you have met one target, and over the over employment you are not able to maintain, so you have taken extra 8 people, and for the goal 3 you have achieved 56, which is more than 55. That means actually you have exceeded the budget by 1 million. So this is how we have utilized the weighted method to find out the solution of the problem. Excel solver screenshot I have given for the benefit. Your benefit, I have put variables, non-negativity constant, both integer as well as greater than equal to 0. So summary of the results of weighted method: goal 1, total profit achieved because it is greater than 125 by 1 million. Part of goal 2, avoid decreasing the employment, we have achieved. because it is not going below 40. Goal 3, budget not achieved because we have exceeded 55 by 1 million. Part of goal 2, avoid increasing the employment level is greater than 40, so not achieved. So 2 achieved and 2 not achieved. Let us see the example by solving it through preemptive method. This weighted goal programming is designed for problems where all the goals are quite important with only modest differences in importance that can be measured by assigning weights to the goals. Now this is the catch where when you will use the preemptive method. Here the modest differences in importance and these penalty weights are given, so you can find out the value of each objective, value of each goal. In case of preemptive method, let us take the same problem and use preemptive method to solve it. Here penalty points are not considered, but the sequence of importance is known as is not negotiable. That means management puts maximum importance on this. So in this case, preemptive method is recommended. So this is recommended when there are major differences in the importance of the goals. The goals are listed in the order of their importance. It begins by focusing solely on the most important goal. It next does the same for the second most important goal, and then it goes to the third goal and then fourth goal, like that it goes. Now in this example we'll see how it goes from first goal to the fourth goal. So first goal is D1 minus. So first goal is minimize W equal to D1 minus. And we solved it. And what we found, actually D1 minus value is 0. Now put this value of D1 minus in the second step. This is the first step. And in the second step, what we do actually, we minimize D2 minus. And in that, D1 minus is a constant which is equal to 0. And we found out the result. We found that D2 minus is 0. This is for step 2. And if you look at the goal 1, goal 2, goal 3, so all results are given here. And here if you see the product combination 5, 1, 4, whereas the previous one it was 0, 0, 9. So as you go on doing going from step 1 to step 2 to step 3, these values of the decision variables are also changing, as well as the values of the goal status. Now we have got two values, D1 minus equal to 0 and D2 minus equal to 0, and put these two values in the third step. So in the third step our objective is to minimize W equal to D3 plus, and we solve the problems again, and we found that D3 plus is equal to 0. So everything changes, and now you find P1 decision variables have also changed and goal status has also changed. So deviation over is achieved, deviation under is achieved, and deviation over for goal 2 is not achieved, and 55 is okay. That means budget is okay. Now let us go to step 4. That means minimize W equal to D2 plus, and I have taken D1 minus equal to 0, D2 minus equal to 0, D3 plus equal to 0. So taking all the values of D1 minus, D2 minus and D3 plus, we solve this problem and we got the value as 15. So this is the last stage of the problem, and we have got a combination of like this: P1 equal to 11, P2 equal to 0, P3 equal to 0. And if you see as the goal status, so for goal 1 it is okay because it has exceeded by 7. For goal 2, the part 1 achieved, part 2 is not achieved because it is more than by 15. Actually it is 55, so it is more than the target by 15 employees. And goal 3, it has been achieved. We are within the budget. So goal 1 is achieved. Part of goal 2, avoid decrease in the employment, achieved. Goal 3 achieved, budget. And part of goal 2 to avoid increasing the employment level greater than 40, not achieved, since D2 plus equal to. It will be 15 actually, so it's over by 15. If we compare both the results, what we observe actually, let us see the combinations of, with preemptive method it is 1100, whereas for weighted method it is 802. And for each goal, goal 1, goal 2, part 2, actually. So in case of preemptive, profit is more in preemptive method. Preemptive method is 132, and employment level over 40 in weighted method. Not okay in both the cases when it comes to overemployment. And here it is 55 plus, that means 15 more, whereas here 8 employees more. Now for the goal 3, budget not exceeded in preemptive. So in preemptive method, the budget has not been exceeded. Now the question is, management has got a lot of insights from both these methods, that whether they will give more priority to profit, or they will give more priority to employment. So whether they should change the priorities, or they should go and take the preemptive method. So, but there is a difference. So why there is a difference? So there is a difference in output results. So where is the catch? If we take the solver screen for the preemptive method, if we take the weighted method solver screen and increase the penalty weights to, say for example 40 to remain same, 30 and 20 for all these variables, we get a value which is the combination P1, P2, P3 as same as the preemptive method. So what we did, actually we increase the penalties and result will be same. So importance, the amount of importance you are giving to the goals will change your results. So if there is a huge difference in the importance, then you should go for preemptive method rather than weighted method. I have given this for your benefit. It was 5243 in case of weighted method, but now I have put this one. So that means profit is highly important than most of the things, and then comes this one 20, 30 for the underemployment, and this one 20 is for the budget. So multiple objective decision making areas. What are the areas? You can use for national budget, save social security, reduce debt, cut taxes, build national defense. Then for colleges, admitting students to college, high SAT or GMAT or high GPA diversity, planning and advertising, campaign budget to reach expenses target groups, choosing taxation levels, raise money, minimize tax burden or low income, minimize flights of business. You can do also planning an investment portfolio. You have some portfolios in the stock market, so you want to maximize the expected earning or minimize the risk. What are the limitations of goal programming? Goal programming provides the best solution under a given set of constraints and the priority structure. If the goal priorities are not aligned with the organization priorities or organization objectives, the solution may not be global optimum. And a clear understanding of assumptions and limitation of the technique is a prerequisite for application of goal programming in your area. What is the way out? World has become really more complex, especially after COVID pandemic, and objectives will be too many and quite conflicting with each other. Please don't run away. Wait. Use boldly goal programming techniques to take advantage of great flexibility, which would allow model simulation with numerous variations of constraints and goal priorities. Wish you good luck. Good news, lots of software available to solve your problems. Formulate the problem and feed it. Results will surprise you. Write to me for any clarification at rabindranath.bhattacharya@yahoo.com. Thank you for listening to my lecture. Thank you for your patience. Knowledge leads you to light and imagination lets you grow. Thank you again for your patience.